Welcome back to AWS On Air with our live coverage from Inforce. I'm A.M. Grabelny. I'm a developer advocate here at AWS, joined by Marie.
I'm back. Hey, everyone. I'm still Senior Manager of Partner Solutions Architecture. I'm happy to be closing out the show with a very special guest that we saved the best for last. So, Ken, why don't you tell us a little bit about yourself and what you do here at AWS?
Great. Yeah, my name is Ken Beer, and I'm a General Manager in the AWS Cryptography org. So we manage a bunch of services and underlying libraries and technologies to help customers secure their data, both in the cloud and on-premise. Been at AWS for a little over 10 years. Excited to be here.
That's a long time. That's like 70 years in AWS years. So awesome. Well, today we're really excited to dive into a few of the launches that you and your team put together that were announced here at Inforce. So why don't you tell us about a few of those?
Sure. So AWS Cryptography, sort of two types of cryptographic services that a lot of people would be familiar with. PKI, public key infrastructure, specifically around issuing digital certificates. One of the things that customers like to do is keep track of identities, both human and system identities, in a directory, right? That's kind of their single source of truth of here's all the assets that I have. And a lot of customers have used Active Directory for that, just given the pervasive nature of AD.
Oh, yeah.
When you provision a new host, especially if it's going to be internet-facing, you got to have a digital certificate on it. So every host itself, it's not enough just to have your fully qualified domain name and your IP address. You want a cryptographic identity. And anybody who's provisioned servers in the past knows that that has typically been, well, I got to go do this other thing to get a cert, and then sneaker net it onto the host.
A cert issuer somewhere. Yeah,
that's right.
Yep.
And so the way that whole process scales and runs a lot smoothly is to automate it. So one of the things we launched with private CA is the ability to connect into Active Directory, so that when you've got new assets that are coming in place, and Active Directory, kind of you register that asset, it can go trigger that host to say, okay, now contact private CA via an API and get a cert for yourself, right? And so
cool.
Now humans don't have to be involved. So now the hardest part of PKI and cert management is trying to remember, like, when did I put that cert on that host, and when will it expire?
When do I have to renew?
That's right.
Always.
Exactly right.
Yeah.
And so AWS Private CA, as well as AWS Certificate Manager for public certificates, handles all that cert lifecycle management, fully automated.
You didn't ask, Ken, but I fall into the system identity side, not the human identity.
Yeah.
Yeah.
That fits.
I figured.
Yeah.
I knew you were thinking that. That's
right.
why I wanted to call it out for sure.
Exactly right.
So what else? What else did we talk about here at Inforce?
Let's see. So in the key management space, so if certificates and PKI kind of is the root of trust for identity, specifically computer identity, KMS is another root of trust for confidentiality. So KMS has been used across all AWS storage services. It is the cryptographic root of trust for confidentiality as well as integrity of data. And KMS has offered ways for you to bring your own keys into the service, right? So for a long time, we said, well, you could bring in a symmetric key because that's typically what you're going to use to encrypt data.
Right.
But now we have an opportunity for you to import in signing keys, or specifically asymmetric keys. Yeah. And there's another kind of signing key called an HMAC key, kind of deep in the woods. Yep.
Hash, hash message
authentication
code.
Right.
That's right. I'm trying to remember my. We were messing with some KMS earlier today.
Yeah.
Okay.
I built a game day for us to play, and
Good.
And we used a symmetric key. Ken, for our audience, I even warned you I might ask you some of these questions.
Okay.
Can you explain for anybody who's new to the security or cryptography space, difference between symmetric and asymmetric key, and keep it to like a 45 to an hour long college level lecture.
All right. Hold on. Let me stretch first.
Yeah.
So symmetric key, the easiest way to think about it, it's a shared secret, like a password. Right? I can encrypt a message with a password. You need the exact same password to decrypt it.
Right.
Right? And the biggest problem in symmetric key cryptography is how do I share the secret?
Yeah.
Right? Because in the process of sharing that secret, if anybody else, an interloper, discovers it, they can now decrypt all future messages.
Right.
So in the 70s, some folks invented, Whitfield Diffie and others invented public key cryptography, right? So now
Diffie-Hellman.
That's right. Diffie-Hellman and RSA and elliptic curve are examples of those asymmetric cryptography. And there, I can distribute a public portion of a key. I don't care if anybody finds it, because you can't take a message that was encrypted under a public key and say, oh, I've got the public key, I can easily decrypt it. You can only decrypt it if you have the private portion.
Right.
And so this is how key exchange happens. Like, for example, a TLS session. You're connecting to any AWS API endpoint, there's going to be a key exchange, right? The API endpoint acts as the web server. It's got a public key. It says, hi, I'm AWSAmazon.com, and S3 is in front of that, or KMS, or whatever the service is.
Right.
And the client says, great, we're going to exchange public keys, and then we're going to use our private keys to encrypt and sign things. And that is a part of a big, long dance that happens in a few milliseconds. So they say, okay, for this particular session, we're going to have a special symmetric key that we use to encrypt all data.
Right.
And you might say, well, why not just encrypt all the data with the asymmetric keys if you have them? And the answer is it's super slow.
It takes longer.
Yep.
Yeah.
That's right.
Symmetric's much faster.
That's right.
But, as you said, you have that problem, how do I get you the key, right?
That's right. So you use kind of a slow but highly secure mechanism to negotiate a session key. So session key negotiation is kind of lingo we use a lot in AWS cryptography, because that is a very common problem. It's undifferentiated. We'd like to do as much of that for customers as possible, and we're always trying to improve the performance.
Yeah, this stuff isn't simple, right?
Yep.
This stuff is actually very, very complex in a lot of ways.
Yeah.
Very easy to make mistakes. It's kind of at the heart of it too is why we use these cryptographic algorithms that were created by PhD level people who, you shouldn't roll your own crypto ever.
Yeah,
in
that's exactly right. And interestingly enough, the underlying algorithms, because they're widely known and they've been studied by academics for years and years, everyone has agreement and general trust in them, but there's all these toolkits that have been built around the algorithms to try and make it easy for developers.
Right.
And one of the things that we've done in the past few years is start to own sort of lower level toolkits. So for example, in the Unix world, there's a library called libcrypt. It's kind of the basis, if you want to use AES or RSA or do a hash, you're calling into libcrypt. AWS now owns its own version we call AWS libcrypt or AWS LC.
Yeah.
And that is baked into other higher level libraries like S2N. So some of our viewers might know S2N is sort of our implementation of the TLS protocol, much more efficient than what you get out of normal OpenSSL, which is kind of the standard open source crypto toolkit. And we are able to take AWS LC and S2N and optimize it for some of our hardware platforms. So things like CloudFront, for example, as a CDN, every millisecond you can shave off of either session key negotiation or the actual transfer and encryption and decryption is a huge win.
Right, it's performance.
That's right. And so we've seen over the past year that they've gotten as much as a 50% reduction in latency in certain types of connections.
Wow.
Through the combination of our own crypto, our own implementation of S2N, there's another protocol called QUIC, the QUIC.
Yeah.
And QUIC, like we're doing a lot in this space to swap out some of the underlying security infrastructure inside AWS. So people just wake up one day and things are faster.
Yeah. Well, and I think that brings me to a good question, because I'm sure people are listening to all of this and saying this is really cool, but how do customers get to the point where they're trusting their cloud provider to be able to hold all of this critical data? You gave a few examples there, but what are some of the things that you guys have been working on?
Yeah, there's really sort of the core of people evaluating, can I use public cloud? Can I put sensitive data in public cloud? And interestingly enough, a lot of people say, well, I have to put the data in a service like S3 if I want to take advantage of low-cost storage.
Yep.
But how can I do that in such a way that it minimizes unauthorized access? Right? And unauthorized access might be another AWS customer, it might be AWS itself, it might be somebody in my own organization that gets creds. So that's typically where encryption plays a role, because you look and say, I've got access control to the system that's holding the data, in order to actually read the data, I now have to have additional access control to be able to use the key to decrypt the data. So it's like a belt and suspenders approach. 2 types of access control, better than one, right?
Yeah.
Yep.
And so that's just any system that uses encryption has to have that, and it has to be fast. And so there's a lot of customers that say, well, what if I put all my data in the cloud, but I hold on to all the encryption keys? And then you have to draw a diagram that says, well, that means that all your data is going to go back and forth between AWS and your on-premise data center so it can get encrypted and decrypted. Can you imagine how slow that's going to be?
Immediately slower, yeah.
That's right.
Yeah.
And
Any
so,
network.
That's right. And so what people have to realize in many ways is that your encryption keys have got to be relatively close to your data.
Yep.
And then they say, all right, but how do I know that you're not going to compromise them? Because I could, in theory, protect my entire AWS ecosystem under one KMS key. Like, what if that leaks? What if you lose it? Right? And so for the past 10 years, we've offered solutions like KMS. Think of it like a multi-tenant hardware security module where it's the safest place to store things. It stores really just one thing, random numbers. And those random numbers are used to protect all of your data across AWS. We have single-tenant solutions, so cloud HSM. Like if you really want to manage the HSM the same way that you have been managing it over the past 30 years, okay, you can do that, right? So we give you lots of entry points. You can bring in your own key. We launched something in reInvent last year where you can actually connect out to your infrastructure to have sort of the root key, the top-level key in the hierarchy, and the data keys that are inside AWS, they can get encrypted and decrypted. So it's kind of a compromise. Trying to meet customers where they're at.
Yeah,
Absolutely.
well, one of the things I was really looking forward to hearing about was the recent release of AWS Payment Cryptography. So going a little bit deeper on like a specific use case. So tell me a little bit more about that.
Yeah, that's a great example. So if you gave me 45 minutes to explain asymmetric, I need
We've got 6 hours, Ken.
45 hours to explain payments networks.
Yeah.
Because they're very convoluted. But the way to, maybe the easy way to think about it is that when you scan your credit card at the grocery store, you've got that information about you and your card number has got to go over a secure network, and there's going to be this intermediary, typically we would call the acquirer, that's got to make some decisions about, are you trustworthy? Is the card trustworthy? Is the kiosk at the grocery store, is that authenticated, right? But then they also have to take that information and pass it over to the issuer to say, hey, do you actually have money in your account? Right?
No.
Yeah.
I can tell you.
Right. And interestingly enough, this sort of a one-to-many type of network interface, and the way you have to transmogrify, as I like to use the word, transform the data to different payment networks like Visa, Amex, MasterCard. You make these transformations, but you can't decrypt the data, right? Everything has to stay encrypted, like from the payment source in the credit card. So you have to use these HSMs because that's where you can do modifications to it, do a decryption event, but then what comes out of the HSM has to be ciphertext again.
Right.
So it's almost like re-encrypting. So PCI, which is the payment card industry, put together, you might have heard of PCI DSS, so the data security standard.
Yeah.
They've got additional standards for these point of sale things, so P2P, P2P is the exact standard. And they are very arcane, and they are very complex, and they've required dedicated special types of HSMs called payment HSMs. And so imagine if you're a fintech company or an acquiring bank or even an issuer that says, all this other infrastructure is just servers and operating systems and app software. I can move that to the cloud. But I have this anchor, if you will, this dedicated appliance. And it's, there are only a handful of vendors that build them. And by the way, to get those things certified, you got to jump through a ton of hoops.
Well,
so,
very high security is required.
That's right.
Yeah.
And so how do you move that to the cloud? Because no cloud provider will take a random customer's appliance and rack it for them, right? So what we did with payments cryptography is we said, okay, we're going to host a lot of these specialized, approved, certified HSMs, but then expose a RESTful API. So rather than this very arcane, pardon the pun, but cryptic application interface to the HSM, we have simple nouns and verbs, encrypt, decrypt, transform, right? And by the way, it all plugs into the AWS SDK. Authentication happens over SigV4. So a developer says, oh, it's just yet another set of APIs from AWS.
I wanted to ask you earlier, Ken, is your team the one responsible for SigV4?
Not directly. So we have some R&D in our cryptography space, especially the ones working on AWS LC and post-quantum, which we should talk about later. So we consult with the identity team, or AWS Auth.
Yeah.
So kind of within the platform and governance organization at AWS, we have identity, authentication, and cryptography. So sister orgs, if you will.
Yeah.
You're all friends.
We're all friends.
It has to go together, yeah. So I know we talked about KMS already and asymmetric versus symmetric, but there's something that I saw was the Database Encryption SDK preview.
Yeah.
I'm all about those those like special things, so I really want to hear about that.
Yeah, so if you think about encrypting any type of system, the easiest way to do it is sort of encrypt all the data, right?
Everything.
So an EBS volume, right? Just encrypt all the blocks, and then when you're ready to read them, you decrypt them, and they show up in memory in your compute instance. Databases have been doing that for years as well. There's certain cases where people want certain aspects of the database, certain elements, to be encrypted under this key, and other stuff to be encrypted under that key. That you can't do at the block level, because blocks don't know anything about fields, right?
Right.
There's
There's
no blocks.
It's just bytes.
That's right.
Yeah.
So now you have to have some application level encryption, some client encryption. And that's always been a challenging problem, because the client that you're using to write to your database may or may not be vended by the database provider itself. It might be some open source thing or something you built. And being able to apply the logic that says, okay, this particular field inside this write, I want to encrypt in this way, that's complicated logic. And then you have to think about, is this encryption going to change, radically change the size of the element inside the database? Maybe it's going to get too big, and my database is going to freak out, right? And then the real killer problem is, all right, now I've got a bunch of ciphertext in this database. How do I index on it? Right? If I can't index my database, it's kind of like, what's the point?
Right.
Yep, exactly.
It's opaque now.
Yeah.
That's right. And so this has been a challenging problem in the cryptography space for a long time. And one of the things that we've done, we have a team called Crypto Tools team that focuses on trying to make developer tools as easy as possible. So, the developer comes in here and uses a tool like the Encryption SDK or the Database Encryption SDK. Underneath it, it's going to use things like AWS LC, but all that stuff is transparent, right? Because what we want is developers to be able to say, all right, I know where my data is coming from. It's either this file, this stream, whatever it happens to be, and I just want to call the encrypt method and be done.
Right.
Right?
Right. Yeah. Oh, wait, you don't want to go for, like 6 months of understanding RSA and doing it by hand,
That's
like
right.
at a master's level.
And
you actually have to ship code? That's crazy. I can't believe it.
Or you're like, well, I'm supposed to have an initialization vector. How big should it be? I don't know.
Yeah.
I want to make it small and fast.
Yeah.
So let's go 4 bits.
Yep.
Is that good?
Setting that IV. You never. It's always. Yeah.
That's exactly right. So this new encryption client, what it does is it allows you to create an HMAC on a value that you're creating, so that you have an index. So you actually can have ciphertext inside the database and do queries against those values without decrypting them first.
Yeah.
Right? So you get some privacy-preserving aspects of the data that you're writing.
Yeah.
And this is a big win. It kind of goes along with other work that we've done in the space. You remember the clean rooms launch that we had at reInvent?
Absolutely.
So we had a different type of client there where 2 entities can both encrypt their data independently, and then you can do operations on the encrypted data itself.
Well, Ken, we joked earlier that we were going to do 6 hours, and I know Maria and I could. We could. This is fascinating. Like I had to stop myself from getting into the random numbers and entropy and how we generate random numbers for cryptography, which is fascinating. We'll have to have you on again.
Okay.
But we have to go, unfortunately. We got to wrap up. Any last words for our viewers? Anything to go check out right now?
Just use more and more integrated AWS cryptography services. It's the easy button, it's affordable, and it's incredibly safe and secure.
Encryption SDK. I'll drop that one too.
Yeah.
All right.
Good.
We'll be right back with our final wrap-up for the day, and we'll see you then.